In the Arctic tundra, late spring and early summer coincide with a significant increase of biodiversity due to the arrival of multiple bird species that come to breed. But those species come from various wintering areas distributed across the globe, often located thousands of kilometers from the breeding sites. So migratory species, by traveling between those areas, are gonna transport energy, nutrients, parasites, and propagals, and also interact with other species. So they're gonna generate a global ecological dynamics between the ecosystems they visit. So the consequences of an environmental change on the wintering area may then be delayed through migratory species to a breeding sites. So for example, the agricultural intensification in North America has provided an important food source for the migrating and wintering snow geese, leading to an overabundant population that caused a drastic change in some of the Arctic ecosystems used for breeding. So our goal was to define a method to characterize a global migration network for high Arctic terrestrial ecosystems. We focus on the Balatalem tundra community located in Nunavut in the Canadian High Arctic. So the vertebrate food web of Balatalem is composed of 35 species, of which 28 are migratory bird species. So to proceed, we define wintering area of each of the migratory species in the food web using a combination of different sources. So distribution maps as shown in the top layer, and then birding observations, bending and recover data also, and finally tracking device installed directly on bird on the study sites. So once we define where each migratory species wintered, we'll obtain the ecoregion associated to this area. So we'll have a global representation of the ecoregion used as wintering sites by the migratory species of the food web. We'll then create a global migration network using the ecoregion connected to an Arctic community by migratory species. So that will be a two-layer network. So the first layer, represented in the yellow circle, represent the species and the interaction between them. And the second layer will be the ecoregion used as wintering area. So represented by the different colored circle. So the structure of the network will outline ecoregion around the globe that have an important conservation value for Arctic ecosystems. And representing the connectivity of a community is the first step in assessing the vulnerability of an ecosystem to external change that can occur in distant but connected environments. So I hope you enjoyed the speed talk, and if you have any question, please come see me at my poster.